Okay, we're going to look at some terminal angles. Our first example, what we're going to look at is they've given us a coordinate, so we'll call this example 1. So they've given us a coordinate that would fall on our graph, and they want to know what the radius of a circle would be that falls on this coordinate here. So the idea is, we'll quickly kind of draw out this coordinate. Let's say this is, I don't know, 2, 4, 6, 8. Oh, actually, that's not going to work well because our 10's not much higher. Okay, let's just arbitrarily kind of draw this point because I haven't fit it on here very nicely. Let's say this is 5, and then about double that would be 10. So this would be the coordinate RP, which is at 5, 10. Okay, this is just a rough sketch of it. Here's our y-axis, our x-axis. What it's saying is that there's a circle, okay, and it's going to fall there, the circle. Okay, they want to know what the radius of this circle would be. So draw in red, because we know that the radius is going to fall from the origin of the circle, which was at the origin of this graph, all the way to there. And we know that point is 5, 10. So we want to find out how long this radius of the circle is. It's the same distance all the way around. Well, what we can do to figure this out is we can turn this into a right angle triangle. In fact, what I can do, we can draw a line straight down there. That's not quite straight. There you go, and shift it. There you go. And we've now created a right angle. Okay. With this 5 and 10, well, we know that this distance here is 5, and we know that the distance upward is 10. So we've now created a right angle triangle where we just have to find the radius of this. And the radius, I'll give you a hint, is C. Do you know a formula that would help us find this C?
Is it S?
It has to do with finding the hypotenuse of something.
Yeah.
Okay. And it usually is written like this. Let's see if you remember it as we write it. Is equal to a squared plus b squared. Do you remember this theory?
Pythagorean.
Yeah, Pythagorean's theorem. Perfect. And what we're solving for is the hypotenuse. The hypotenuse is opposite of the right angle. So we'll quickly plug our values in and solve for c. So c squared, which is really the r. In fact, what we can do is we can call it r because it's the radius of the circle. Okay, the same idea. R squared is equal to, and it doesn't matter which I call a and which I call b. So we'll call a 5. Okay, that was my side a, and this will be my side b, plus 10 squared. R squared is equal to 25 plus 100. R squared is equal to 125. And now technically, R is equal to the square root of 125, which is some decimal, okay? In this question, they wanted the exact value. So if we brought out our calculator, we could quickly, let me get rid of all this, yeah. The square root of 125 is this. And as soon as I stop there, it actually goes on for farther. So I'm not actually being 100% accurate. What they're looking for is written as a radical. They want the answer written this way. So you would say C or R, in our case, I'll write it in green. So I'm going to say C is equal to R, which are the same thing, which is equal to root 125. So that's how long the radius of this circle is. They want it as an exact value, so we leave it as a root. Okay. Example 2. We have a unit circle at 170 degrees. Kind of a different idea. We've already drawn it above, so I'm going to move this stuff down and kind of make a second part. Here we go. Okay, so this is kind of our part 2. We have a unit circle, and a unit circle means that the radius of the circle is 1. Okay, so we'll quickly kind of draw a unit circle here. Its radius is 1. So here's our unit circle, and maybe, I guess we won't zoom in. What's happening here is the radius, so from the middle to the top, is a value of 1, okay? And it says it's 170 degrees. Well, 170 degrees, we know that this is 90 degrees, and all the way over is 180 degrees. This would be, we drew a flat line from here to here, it's 180. And if we go from here to here, the y-axis, that's 90 degrees. Okay, here's our x-axis. So we know 170 is, and we're just going to kind of draw a rough sketch of it in, is probably about there. Okay, 170 would be, this is a rough sketch again, about that far. That's 170 degrees of a unit circle. The radius is still a distance of 1. In this question, they want us to find what the coordinate would be. So this is our P, this is our P, and X and Y. Okay, so they want to know what the coordinate would be. Well, we can do the exact same thing we did before. We can create a right-angled triangle. The angle under here, because this is 180, we just take 180 and subtract 170. So 180 subtract 170 gives us 10 degrees. So we know in this little triangle we have 10 degrees. So I'm going to kind of blow it up so it's easier for us to see. Okay? Okay, so that this is 10 degrees. We know this is 90 degrees, which means this by default is, I'm going to tell you, just 80 degrees. And you would have just taken 180 subtract to figure it out. And the radius is 1. So the goal here is to figure out what this and what this are. Because they are going to give us our coordinate. This one will give us the x value of the coordinate. And this one will give us the y value of the coordinate. Okay, so we got to use our primary trig ratios, so SOHCAHTOA and such. Okay, because I know this is 10 degrees, if I want to find the opposite, which is y, I know that's going to be sine. Sine 10 is equal to opposite, which is our y, over the hypotenuse, which is 1. Okay, I would bring 1 over, so I multiply by 1, and 1 times sine 10 is just going to be sine 10 is equal to y. So we're going to use our calculator. I have to use this one because it's in degrees. 10 sine is 0.17. Okay, so y is equal to 0.17. I guess I should write that in red. Y is equal to 0.17. So what that means is the height of it, of our coordinate, so if we're writing our p, the height is at 0.17. That's the y value, okay? If we want to find the x value, I can do cos. Cos 10 is equal to adjacent. This is the adjacent side over the hypotenuse, which is 1. Same idea, we multiply by 1 and won't change anything. So cos 10 equals our x value. That's our unknown, okay? So we find out what cos 10 is. 10 cos 0.98. So x is equal to 0.98. So the x coordinate is 0.98, which makes sense, right? Because our radius is really small. It's right in there. Okay, so we know they're going to be less than 1, and it's pretty close to our x-axis in that coordinate.